Hello guys, welcome back to class. So in this session, we'll continue the literals. We'll finish the remaining literals. We'll start with floating point literals. In the previous session, we have done integer literals. Now the floating point literals. Floating point literals. Floating point literals, you can assign to float data types. Can be assigned to float data types. Floating point data types called 2. Float comma double. We have two data types only. Integer 4, here 2. Float takes 4, double takes 8. Float takes 4, double takes 8. So when you have a smaller numbers, go for the float, and bigger numbers, go for a double. But in this, default is the double, guys. What's the default? Is a double. Like in the integers, byte short, int long. What is the default? Int is the default. Similarly, here between float and double, default is the double. They made default as a double. So most commonly we use integers means we'll declare int only. There's a most habited. And floating points mostly we will use double. Right? So these are the defaults actually. Right. So the defaults. Now, any floating point number you have, you can assign to float or double. And to represent, if any float you are representing, if you say float f equals to 9.9. Now, this line, will it work or any error chance is there? Tell me. Any error chance is there or it runs? There is a chance, right? Your guess may be. See, I just now told default floating point numbers, it will consider as a double, right? This will be considered as a double. Double means bigger. Assigning to float, smaller. Whenever you try to assign higher to lower, bigger to smaller, possible lossy conversion problem will come. Incompatible types, right? This gives the error. Then you say 9.9 is not the double. You say it is a float. How to tell to compiler? My dear compiler, 9.9 is not the double. Please don't take that as a double. Please take it as a f. Float, you say f means the float. Suffix f means the float. Similarly, f can be again a smaller capital, guys. And I am saying double d equals to, say, 9.9. Now 9.9 by default will take as a double only. Double I am assigning double, no problem. But still, if you want to say, you can say d also here. Double values can be suffixed with d in a smaller capital D, and floating point numbers will be suffixed with f in a smaller capt. Okay. Now, floating points can be represented again in 3 ways. You say three types of floating point literals. 3 types you say are 3 ways to represent any term you can use. 3 types are 3 ways to represent. Number 1, decimal notation, just representing as decimal. Number 2, you call as a scientific notation also. Second is scientific notation. Vishnupriya, in the case of double, D is the optional. In the case of double, D is the optional. D is the optional. D optional. But F mandatory or optional? F mandatory or optional, guys? F mandatory, very good, very good. F mandatory, D optional. D is optional. So scientific notation, or you can also call it exponential notation. Exponential notation. And third introduced in Java 5 is hexadecimal notation also. This is newly introduced, hexadecimal notation. How many ways are there to represent the floating point numbers in Java? How many ways are there to represent hexadecimal numbers? Floating point numbers in Java? 3 ways. Decimal representation, that is a standard floating point notation. Decimal representation also called as standard floating point notation. How normally floating points will be represented with a decimal point, right? Decimal point related. Scientific or exponential hexadecimal notation. 3 ways to represent your floating point literals. Start exploring each one. Go to the next page. So first one, what do we take? First one is the standard notation or a decimal point notation. You can call it as standard notation or standard floating point representation. Standard floating point representation. In a standard floating point representation, you write normally 1, 2, 3 dot 4, 5. Just write a floating point enough, right? You write multiple 1.1, 9.9, whatever. If you have more precision means 9.99999. You have to write like this only. This is the standard notation. Do small labs on this. 52 done, 53 guys. Double D1 equals to 123.456. The basic notation I am using. Next, double D2 equals to any number you want, you can say that. 2345 dot 6789. Either smaller or bigger, you can just say. Now, this program, you tell me, with the knowledge points we discussed, will it compile or not? Will it compile or not, guys? Default type is double. So this is a standard floating point notation. And by default, consider as a double. Double to double, same, compatible, no problem. This is standard floating point representation, which is considered as a double by default. Double to double, okay, this is D2. Done. I think this is super cool. This compiles and runs successfully. Simple lab, right? Standard notation we are using on this. 53. Okay, nothing. Here is the test for your brain. I am thinking it will compile. Is that okay? Why error? Why error, guys? By default, this number is a standard floating point representation, will be considered as a double higher, you're assigning to smaller. So incompatible types, right? This program has to compile time error called incompatible types. Possible lossy conversion from double to float. It has to show clearly double to float. Possible incompatible types. Possible lossy conversion from, you have to by heart this, incompatible types. Possible lossy conversion from double to float. See, it is considered 123.456 as a double only. It is trying to convert from double to float. F1 is a float only. That's what clearly telling, sorry guys, I can't convert this. There is a chance of loss of data because of this conversion. Possible lossy conversion. So compile number 55. How to correct this then? If you want a float, represent f as a suffix. Then no problem. Now this number will be considered as a float. Float value, which variable? Float variable. Float value you are assigning to float variable. Float to float compatible. No objection from compiler. This 55 has to be compiled and executed. Done. But see, when you're printing, it won't print f. Remember it. Floats, when printing, it won't print f values. Print, it won't print the f values. Okay. Next is the exponential notation or a scientific notation. Number 2 is exponential or scientific notation. You can also represent in this way. So, have you seen sometimes you used to do like 9.9 into 10 power 5? Have you represented this? This is called as scientific notation or exponential notation. Can I represent a floating point numbers like this also? Yes, 10 power 5 you can say, or 9.9, not only 9.9, anything. For example, I am using 123.456 into 10 power 5, 6, whatever powers. 123.456 into 10 power minus 5. Like this you can represent. But in our program, how you write 10 powers? We can't write. So this, how you represent like this means 123.456. Wherever a 10 is there, you use the E. Wherever 10 is there, use the E. E can be again a small e or capital E. After E, immediately write the 5. E5 means 10 power 5. And this 123.456 E. E can be small or capital, I told. After E, you write a minus 5. So this internally will be converted like this and evaluates and gives the standard output only finally. So this notation is clear? Okay. 56. One small lab on this. First I am taking float E, E2. E2 means 10 into 2, 10 power 2. Double D1 equals to 123.456 E power 2 plus 2 or minus 2, whatever. Okay, this is D2. Okay, guys. Now in maths, you will scientific, you will give only 10 power. In mathematics, in scientific notation, when you represent a floating points, I think other than 10, you don't have anything. Only 10 powers you represent in maths. Only 10 powers you represent in maths. Whatever you have in maths, same thing represented here. But when you print it, guys, when you print it, right? So question from Pavan is, if you take 123.45 E5, won't be considered as an integer. No integer, because all a decimal point is there, right? You have a dot here. Decimal point is there. Whenever you are using E here, whenever you are using E, the final result will come as a floating point number only. That E representation is only for floating points, not for integers. Integers already we have seen all the options. Integers, 4 styles. That's it. E you are writing in your number means that is a decimal number. That is a decimal number. Floating point number only. There is always a floating point number only. Okay. But when you run it, anyway, your compiler finally converts to the full standard floating points. No e's will be there. Compile the 56, guys. It is evaluated and giving the results. How the result comes, I think you can do the maths, right? This is E2 means nothing but 10 square means into 100. Into 100 means the points, 2 points changed. 45.6. And this is 10 power minus 2 means by 100. By 100 means decimal points will change towards the left side. That maths you know, I think, right? Is that clear, Pavani? So I'll give you test more than, see this, Pawan, 56A. This is not there in booklet. This is not there in booklet. You do this and tell me. Int x equals to 123 E2. Capital A I am using, E2. You tell me what happens with this lab. 56A, which is not there in booklet. Tell me, guys, if you understand a standard floating points, scientific notations, you have to answer this point. Why semicolon expected? I have written a semicolon, Pavani. Why error, Anand? Why error, Shekhar? Why error? Dot is not mandatory in the, if I don't have any fractions, why to represent, Anand? I don't have any fractions. Suppose say, Anand got 90 marks. 90 marks. Okay. And say Pavani got 90.5 marks. Pankaj got 90.9 marks. So because they got it, I am writing here. Anand got 90 only. I am not writing dot 0. If if you are not writing also, maybe it can be considered as 90.0, right? So 0.0 can be added for that. It is not mandatory to write a decimal point for the floating point numbers. Remember it. If you are not writing 99, okay, it is equivalent to 99.0. This basic conversion compiler will do for you. Compiler will do for you. So what is the E can be capital or small? Vishnu Priya. I told E you use anything. E can be capital or small, both are allowed, no problem. Hari is telling that provided double required integer, incompatible types, maybe the guess, right? $56A, guys. See. What happened finally? See, this result evaluated 123 E2. It seems like integer only, guys. It is 123 E2 means 123 E2 is nothing but 10 square means 100. It is 12300. It seems integer only, but because E is used in that, the result should be the floating point. It gives us 123.0. 123.0. What's the result is coming? 123.0 is coming. So that is a double value again. So because of double value, there is a floating point value. In floating point, the default is a double. So consider the result 12300 as a double. but you assigning to the x integer. So telling you can't do that. Double to int, result is double. Possible logic conversion, incompatible types. I think we reached it 110 times as of now. Correct? We'll comment this line. I'll comment this line and I'll do this now. DOUBL. Double x equals to 1, 2, 3, E2. Now is that fine? Now is that fine, guys? My result is coming as a double only. Was the result coming, guys? Was the result coming up? 1, 2, 3, 0, 0, dot 0 is coming up. This is a double. I'm assigning to the double variable x. So happy x prints that as 1, 2, 3, 0, 0. See that now? Compiled successfully, guys. See the result 1, 2, 3, 0, 0 dot. Yeah, if you want to make it as a float, yes. Srinivas, you are right. If you want to make it as a float, comment it. Now, if I do this, float x. Now tell me what happens. This line, what happens? This line, what happens, guys? Error, because the result is coming as a double. Remember, result always the double. Result the double. Double to float again. Possible lossy, incompatible types, possible lossy conversion. Very good, guys. You got the point now. See? Conversion happening from double to float. You tell that I want the result as a float. I want the result as a float, guys. Comment this error line also. That will be useful for your practice. When you do experiments, you do that. Now, is that fine? I am asking, I don't want a double. Make this float. Yes, make it as a float. No problem. Done? So, is that clear, guys? Scientific notation also we're done. This lab is not there. You write down later and do the experiments on this. So what is the third option? Third option is hexadecimal. This is added from Java 5. Hexadecimal. Hexadecimal floating point notation. From Java 5. Okay. So here hexadecimal means then basics, right? Everything they given under a basics model. Hexadecimal means base 16, sorry, not 6. Base 16. So how you write the notations here? Double, suppose d equals to, because it is hexadecimal, you have to start with 0x first. Because of hexadecimal, you start with 0x. Okay. Then you write the digits. Hexadecimal, what are the digits allowed? 0 to 9, here you have 16 digits are there. You write whatever digits you want. After that, you write a P. P mandatory. You write a P power anything. P0, P1, P2, Pn you write. Pn you write. This is the notation you write. For example, double d equals to 0x. Suppose 1a dot 1a p2. This is a valid hexadecimal floating point number. This is a valid hexadecimal floating point number. Let me take this as a bit bigger. Double d equals to 0x 1a dot 1a p2. And here p, this is hexadecimal, but the p is the power 2. This is the 2 power actually. Here P2, whatever you write, that is equivalent to 2 power, P means 2, 2 power 2. 2 power 2. Decimal point is there here. This is hexadecimal number. What are the positions of the hexadecimals? What is the weight of each decimal, guys? What is the value of this? What's the value of this? Is this A is 16 power 0? 16 power 0. And 1 is 16 power 1. Like this, we have something. Let me take one more, for example. Here I will use 2, 1, something like this. What's the value of 1 again? 16 power 2. And this is 16 power 3. And after decimal point means it is coming as a by 2. I think you know, if you take the decimal numbers, guys, I am taking 123.45, for example. Oh, you know the same thing in decimal number, or they are doing in 123.45. Is it a decimal number? Consider as a plain decimal. What is the power of this, guys? Position of this. Is it 10 power 0? Correct? 20 means 10 power 1. This is 100, 10 power 3. Sorry, 10 power 2. Correct? After decimal point, tell me. After decimal point, tell me, guys. How good you are in maths, I don't know. What is the position of 3 is a 10 power 0, correct? And 2, 10 power 1. 1 is 10 power minus 1, guys. Very good. This is 10 power minus 1. This is 10 power minus 2. That's it. After decimal point, it will go minuses this side. Same here. Because it is hexadecimal, what is the 1's position? 16 power minus 1. A's position, 16 power minus 2. Like this. You will do this is a formula for calculation. So we'll take one small example and do the calculation, guys. For example, I'll take a new. I'm taking d equals to 0x 1 a 2 dot a1, anything, and a p2 I am writing. So tell me the positions of this. Tell me the position of this. This is 16 power 0, 1 and 2, and here 16 power minus 1, 16 power minus 2, and p means 2. This is equal to 2 power 2, right? Positions are written. Now do the calculations. How you do the calculation is, you start 0x is a notation, just notation, that will not be a value. So it takes as 1 into 16 power 2, am I right? Plus a into this 16 power 1 plus 2 into 16 power 0. This dot also make it plus a into 16 power minus 1 plus 1 into 16 power minus 2. This whole expression into P2, 2 power 2. This is how you calculate. Do this. 16 power 2 means 16, guys, 256, am I right? 256 plus. This is a power 16 power 1 means 16. A means what? What is A in hexadecimal? A is the 10. 10 into 16, 160 plus. This is the 16 power 0, 1. 2 into 1, 1 plus. This is A into 10. 10 by 16, correct? Is it 10 by 16? Plus this is 1 by 16 power minus 2 means 1 by 16 square means is it minus 2? Yeah, correct. 1 by 256. This whole you calculate into 2 power 2 square means the 4. So can you do the math, guys? 256 plus 160 plus 1 plus, what is this, 10 by 16? Do you have a calculator? Can you please do that? Do you have mobile, I think, with you? 10 by 16, are you doing, or can I do? Please do. 10 by 16, guys. 10 by 16 means 0.625. Okay. 0.625 plus 1 by 256. 1 by 256, guys. 1 by 256. 1 by 256. 0.0039, okay. 0.0039 into 4. What is that? You do this math. 256 plus 160, how much? Plus 1 plus all. Please do this. Addition of all. 1, 2, 3, 4, 5. Addition of these 5 do. Tell me the sum. 200, 300, and 400. 400 and extra we have a 16, 17, 417.628. 417.6289. Am I right? 6289 into 4 do. Into 4 do. 1670. 1670.5156. So if you write this hexadecimal number, this is the decimal equal. What's the hexadecimal you are writing? 0x1A2.A1P2. This is the hexadecimal valid notation you write. This is the equivalent to this number. So the formula is clear. Formula to calculate, go back to the labs. 1A2, A1P2. Okay. Now 57 we do. Okay. Double D1 equals to 0x required, guys. 1 A2 dot A1 P2. P also again a smaller capital you can use. What is the value we just now checked? That value is coming or not, we'll see. Is it correct? A1 to 1A2 A1 P2. 1A2 A1 P2, correct. So output should come as a 1670. Then our formula calculation also correct. Oh, I did something. That is my mistake. It's a D1 actually, right? One 1674.515625. Yeah. So you got the output. That's the formula. We'll do more experiments on this, guys. You make this as a D only. Whatever formula we calculated, keep this. I will do smaller values. You tell me the output of that. Double D1 equals to just A only I'll use. A can use the smaller capital, anything smaller capital. Okay. I'm using P0. Tell me the value of this. You calculate and tell me the value of this, please. D1 value. Tell me. No decimal point. My wish. No decimal point, decimal point is not there. 10 or 10.0. 10 or 10.0, guys. 10.0. A is the 10. 10 into 16 power 0. 10 only. Into P0 means 2 power 0. 2 power 0 means the 1. 10 output will come. Yeah, 10. Now tell me, I'll just do small change on this. P1. P1. Now, D3 as P2. P2. D2 is the 20.0 and D3 40 only, not 400 power. 40. Yeah. Okay. Like this, you can write the numbers. Done. So notation we understand, and we've done the formula calculation also. You will get the respective values. Okay. So twist means what we can't do. What we can do, we learn. Now everything we are learning, what we can do. Yes, we are learning. What we cannot do means we are doing mistakes. Can I do this? Can I do this? Can I do this? Mistakes we are doing and understanding. If you do that, you will get a trouble. Okay. And A12. A can be a small also, no problem. A12, guys. A12. Decimal point, if you want to write, you can write A12.12. No problem. Tell me. No need to calculate actually. Here, the point to learn is you see that output and tell me. You are not writing a P notation, right? Malformed floating point literal. It means syntax wise, compiler telling it is something wrong in the syntax. This literal something wrong. What is something wrong? P notation is missing. P is mandatory. Worst case, you write a P0. P0 means 2 power 0. 2 power 0 to 1. When you multiply with 1, doesn't make any change, right? So at least you have to write a P0. Mandatory. P is mandatory. So if I am not writing that, compiler gives error. So this program is giving compile time error. 58 is done. So that is with the floating point literals. 3. Standard notation, scientific notation, and floating point representation with the hexadecimal notation. 3 options we studied. After the floating point, we have one more called the null literal. So null is the default value for all the reference variables, right? Null is the literal, which is the default value for all the floating point. If you are not assigning anything to the reference variables, it will automatically assign the null value to that. Or you can explicitly even assign the null to that. 59, nothing to study much about that. We know already about this. 59. String str1 equals to, because it is a local variable, I am explicitly assigning the value. Or you make this str2. Let me to make one static variable. This is static str1. str1 static means I no need to assign a value, right? So when I print str1, what value will be displayed? str1, whose value null? str2, also the value null. Who is initializing str1 with the null value? str1, are you initializing? I am not initializing str1. JVM initializing means JVM also knows that reference variables default is null only. And we also know null. We are initializing. str2, we are initializing. JVM is not initializing. Done. It prints just null and null. So about a null literal, this much is more than enough, guys. Null and null. Right? Now, there is a one more notation given. It is just easy readable purpose. They given this. The last one in this module. This is underscore in numeric literal. What are the numeric literals? We have seen the literals. Literals are boolean literals, char literals, and string literals, integer literals, floating point literals. We didn't see numeric literals anywhere. What are numeric literals? I didn't touch this. Can you guess what is the numeric literals? Tell me, guys. What are the numeric literals? Numbers, guys. Numbers are of 2 types in maths. Numbers are of 2 types. Integer numbers, floating point numbers. Numeric literals are nothing but integer literals and floating point literals. We studied integer literals separately, floating point literals separately. Integer literals, the 4 ways to represent. What are the 4 ways? Integer literal can be represented as a decimal integer literal, octal integer literal, hexadecimal integer literal, binary integer literal. Floating points can be represented in 3 ways: standard notation, standard decimal point representation, scientific or exponential, and hexadecimal notation for the floating 3 ways. These all are called as the numeric literals. All styles. Integer literals, integers are numbers. Floating points are numbers only, right? Both are numbers. Numeric literals. In numeric literals, we can use underscore. Why we use underscore in the numeric literal? Okay. Now, when you're writing normally in the book, in a paper or a book, when you write, suppose 75 lakhs 23,560 rupees. Suppose you have this much salary you are getting. In this, why comma here? Can I also write like this? 75,23,560. This both are right in maths or not? Both are right or wrong, guys? Both are right or wrong? Both are right. Which you like? First one, why? Why? More readability, easy to understand, right? Easy to read. Our brain will recognize that easily and we can read easily also, right? Similar idea they provided in Java also. Can I write a commas in my number in Java? Go to the lab number 60. Can I do commas like this in Java? In book you write, in paper you write, but in computer program, can I write that? Maybe doubt. You take suppose int x equals to 75 lakhs 23,000 for some 5654 whatever. Can I do this? Not allowed, guys. That is commas not allowed in the numbers. Commas, any numeric literal. It can be an integer literals or a floating point literals. Commas like this not allowed in Java program. When commas not allowed, how can I make that as a readable, guys? You ask the compiler, see how it will scold you. 60. It is not understanding something. 3 ways, 3 errors, 1 mistake, 3 errors given. So anyway, underscore not allowed. Then how to make my program readable? Yes, if you want to make the readable, they give an option for you. Use the underscore. Compiler will accept this. Wherever you want to make a clean separation like this, you make the underscore here. It doesn't make your value, guys. It doesn't change your value. Underscore doesn't change your value. It just a notation, a representation for easy understanding of the numbers, easy reading of the number. The value remains the same. So now underscore is there. We have separation 75, 23, something like that. You can understand. But when I print x value, what it will print? It will print the number 7523, whatever the number is there. 75 lakhs. Can I store in the integer? Is that an integer range? Is that an integer range, guys? Sorry, 61. Compiled successfully. When you are using that in, it is in integer only. Nagatrisha. 752. Integer range is 241, means 214 crores, 200 crores is the max limit, 214 crores is the max limit for integer. You by heart that, 214, something like that. Okay? Done, guys. Like this, you can use the underscore also. So when you're using underscore, there are some rules to follow. We can't use as you like. To use the rules, uh, before telling the rules, I'll do some experiments on this. Lab number 61. Okay. Now, I'll do like this. Underscore 123 I'm using. Int equals to underscore 123, guys. What is the x value to print? Here, they put a restrictions that don't use underscore before and after. The reason is, now I want to declare a variable, guys. I am declaring a variable. When I am declaring a variable name, I have to follow the identifier rules. Can I declare a variable like this? Underscore integer underscore 123 equals to 99. Can you tell what is this expression? What is int? A data type. What is underscore 123, please? Is that a valid variable? Is that a valid variable, guys? Yes. Underscore 123 is a valid variable. Equals to operator 99 is my literal. I'm assigning 99 to my variable called underscore 123. So the conflict here for compiler confusion is, if I write like this, what is this underscore 123? What compiler has to treat? Is it you are writing the underscore in the numeric value, or is it the variable? What it has to consider, guys? Do you understand the point? If I write int x equals to underscore 123, whether compiler has to consider underscore 123 as a variable, or this is a value with something. So confusion, because that's what they read. Underscore they're not allowed in the before. First, if you write underscore in the numeric, that will be treated as a variable only. That will be treated as a variable only. Now, have you declared the variable underscore 123? Have you declared a variable underscore 123 in this program? So when I compile this 61, what happens? It will give compile time error, right? What's the compile time error? Cannot find symbol. Symbol is cannot find symbol. Symbol is variable underscore 123. Your compiler clearly identifies underscore 123 as a variable, and variable underscore 123 is not declared by you anywhere. So it gives error that cannot find a symbol. Symbol is underscore 123. Ask the compiler. See, cannot find symbol. Which is symbol? Variable underscore 123 considered as a variable. So can I declare the variable like that? Yes. Underscore 123 equals to 99. I am right. So first I am declaring a variable underscore 123, guys. I am assigning a value 99 into that, and I am printing the variable underscore 123. Can I print? Yes. Underscore 123 printed. Now the variable underscore 123 having a value 99. 99 I am storing in x. X again I am printing. What is the output of this program? Just 99, 99. So can I use the underscore at the beginning of a numeric literal? This whole story I told you only to say underscore cannot be used at the beginning. Now you'll ask a question, what will happen if I use underscore at the beginning? If you use underscore at the beginning, it will be considered as a variable. It will be considered as a variable. 61 now compiles and gives the output. Right. Now 62 already we discussed. You have to answer this program. I'll just cut some piece of code from this. That's it. Tell me what happens now. What I am thinking is underscore 123 is the numeric literal. Numeric literal I am assigning to x, x printing. I think it prints the output 123. Error. When you use underscore before, that will not be considered as a numeric literal. That will be considered as a variable. Underscore 123 now in this program will be considered as a variable. Have you declared the variable? You did not declare the variable. Compiler will come and stop you and ask, where is this variable? Right? Error will come. 62 error message will come. Same underscore can't find a symbol. Done. 64. Similarly, 62 to 63. So you may have a numeric literal, means it can be anything, right? Numeric literal means it can be an integer or a floating point. If integer, it can be an octal integer, decimal integer, floating point integer. Till now we discussed about decimal. If it is octal, where it is allowed, where it is not allowed. So multiple options we have. Suppose I am taking int. Octal means you write 077, right? Octal means 077. Is an octal some number? 0 starts with. After this, you can use, guys. Even after this, you can use. After this, you can use. Anywhere, you can use this. Print this x value, variable a, whatever. 3. Okay. Then I'll use byte b equals to, we have binary related 0b, 0b. After that, digit I'm writing 1 underscore 0 underscore 1, for example. Okay. B. Enter C equals to 0x 1 underscore a underscore b, 1ab. If you remove underscores, that is our whatever we discussed previously, right? Similarly, double floating point related, double some d equals to, suppose 1 underscore 2 underscore 3 dot 4 underscore 5. Print that. These are possible cases. Yes, you can do like this. All right. Possible case 63 will compile and run successfully, guys. Wherever you can use underscores, I just given the possible cases where you use underscores. Finally, 63, the value, whatever is there. Where you cannot use, I'll show in one lab, the last lab of this particular topic, 64.show. Where we can't use this, 64. Right? In a number, if you take suppose 1, 2, 3, can I use at the ending? Can I use at the ending of the number? No. Beginning can't be used, ending cannot be used. And binary related 0b, after 0b, immediately not allowed, guys. 0b, after 0b, then you write at least one digit. After one digit, you can write whatever you want. But immediately after 0b, not allowed. Immediately after 0b, not allowed. Similarly, hexadecimal, immediately after 0x, not allowed. But in the octal, can I write immediately after 0, 7, 0, 1, 2, 3, for example? Can I write immediately after 0 in the octal? Can I write immediately after 0 in the octal? Yes, that I shown in the 077, I shown 077. Immediately after 0, I can write. But in the binary representation, 0b immediately not allowed, 0x immediately not allowed. At least 0b, one digit you write, then you write whatever. 0x, one digit you write, then whatever you want, you can use. So immediately after 0b, not allowed. Immediately after 0x, not allowed. Immediately after 0 in the octal, allowed. And in the decimals, immediately after decimal, before decimal point, not allowed. After decimal points, not allowed. One I'll use in this. D1. After decimal point, immediately not allowed. So these 5 cases, anyway, before beginning not allowed. Beginning means it is considering as a variable, different problem, we understand that. Last not allowed, after 0b immediately not allowed, after 0x immediately not allowed. In the floating point numbers, after decimal point not allowed, immediately. After, before decimal point immediately not allowed. Other cases you can write, no problem. So these are all 5 cases, not allowed cases. Clear, guys? Not allowed cases clear? All illegal, illegal, illegal. Illegal underscore. Simple. This is error message is they design error message very neatly. See, at the end, I want a red color. Yes. At the end, guys, illegal underscore. Immediately after 0b, illegal. Immediately after 0x, illegal underscore. 1 minute. Okay. Decimal point just before, illegal. Decimal point just after, illegal. Okay. And that's it. One more point. You can use more than one underscore also, no problem. Doesn't make any difference. In between, you use 64A I am writing, which is not there in the booklet, it means. I'll just take one. System dot out dot println of A. So before, after, not allowed. In between, you write. So 1 underscore, 2 underscore 3. Is that okay? Okay, right? Yes. Now, 1 underscore 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 2 underscore underscore something like this. Is that okay? Yes. You can write many underscores also. Doesn't make any difference. This is allowed. Side by side, n number of underscores are allowed. Finally, the output of A is, A value is 1, 2, 3 only. A value is 1, 2, 3 only. Compilation done successfully, guys. Output is simply 1, 2, 3. Done. So we have completed all the literals, guys. 64 labs as of now. On the literals, there is again assignment and practice test. Let me to go and check that, whether it is with me. This part 2 booklet you have already, guys. Literals regarding. So your next job is, we have done this in this session, previous session. Previous session, we have done the integer literals. So all of this we have done: octal, hexadecimal, binary, then floating points, whatever we seen, right? Then hexadecimal calculation, null, literal, underscores. We have done all of this. Now you read all the points. You read by heart each point given here, important points. You see, for example, underscore in the numeric literal, guys. When I am explaining in the lab, I am showing practically also. Here given, see, we can use underscore in the numeric literals to represent the unit of values from Java 7. This is added from Java 7. When underscore is used before the first digit, it will be considered as variable. Point discussed. You can't use underscore after last digit. We tested practically. In the case of octal, underscore can be used just after 0. After 0 in octal we can use. But in the case of binary literal, underscore cannot be used after 0b. In the case of hexadecimal, underscore cannot be used after 0x. We can use underscore in between more than multiple times also. More than one underscore also can be used. You can use underscore with the floating point literals. But not allowed just before and after the decimal points. See, all the points are recorded. This is what you by heart, practice the labs, it should be in your mind. Now, you have to start working on the assignment 3, page number 66 and 35 questions. You have practice test 3 on this. You have to do this, guys. Okay? You have this booklet already with you. That's the end of literals concept. We'll start with another concept in the next session.